Hello everyone. Let us learn today about aldol condensation reaction. So what is aldol condensation reaction? It is the reaction of aldehydes or ketones to form beta-hydroxyaldehydes or ketones in the presence of dilute NaOH. So this further can be dehydrated to alpha beta unsaturated ketone or alpha beta unsaturated aldehyde. So let us see in first what are aldehydes and what are ketones. So aldehydes have the general formula R, C double bond O, H, and ketones have the structure R, C double bond O, R. So here in aldehyde group there is one R group and on the other side we have hydrogen. In the ketone group there are two R groups. These R groups can be same or different. So let us write something about aldol condensation. It is the self-addition reversible reaction of aldehydes or ketones in the presence of dilute base to form beta hydroxy aldehyde or beta hydroxy ketones. Further, they can be hydrolyzed. Sorry. Further, they can be dehydrated to form alpha, beta, unsaturated aldehydes or ketones. So, let us see the conditions for aldol. So, for aldol condensation reaction to occur, aldehydes and ketones must have alpha hydrogen atom. So, let us take first example where we have acetone. Here, adjacent to the carbonyl carbon atom, we have two alpha carbons. So, here we have 3 alpha H. Here we have 3 alpha H. So, in total, we have 6 alpha H. So, next example is acetaldehyde, where we have 3 alpha hydrogen. In next example, we have formaldehyde, where we don't have any alpha carbon atom. So, there are 0 alpha hydrogen. In the next example, we have acetophenone. In acetophenone, there are 3 alpha hydrogen. In the next example, we can take butanone, where we have 2 alpha carbons and in total we have 5 alpha hydrogen. In the another example, here it is cyclohexanone, where we have 2 alpha carbon and 4 alpha hydrogen. So let us discuss the general reaction of aldol condensation. So aldol condensation reaction, we have 2 molecules of acetone, where it undergoes aldol condensation and addition reaction to form a beta-hydroxyketone. So we can write the product in this way. So this is alpha, here it is beta. On the beta carbon atom, we have hydroxy group, so we can write it as beta hydroxy ketone. So this is the general reaction for any aldol condensation to occur. So now we can write the mechanism of aldol condensation. Aldol condensation mechanism can occur in two mediums, that is basic medium as well as acidic medium. So let us see first what happens in basic medium. So the first mechanism is in basic medium. So let us take acetone. So in the presence of dilute base, it abstracts proton from the alpha carbon to form enolate ion. This undergoes resonance to form enolate ion. So in the second step, what will happen? This enolate ion will attack on the carbonyl carbon of acetone. Now this attack will take place on the carbonyl carbon. As carbonyl carbon atom is acting as an electrophile, and enolate ion will be acting as a nucleophile. So this carbon and oxygen bond is polarized. So oxygen acts as partial negative charge and carbon acts as partial positive charge. So here we get as this is the anion formed by this addition step. Now this step is the RDS of the entire reaction. So what is RDS? RDS is known as rate determining step. Rate determining step is the slow step which occurs in the reaction. So for this aldol condensation, attack of the enolate ion on the adjacent carbonyl carbon of acetone is the rate determining step. So in the last step, we can see that we have this anion which will now abstract proton from a water molecule. So now it will form beta-hydroxyketone. So here we get our product as beta-hydroxyketone. Now this can further act as, this can further undergo dehydration to form alpha-beta unsaturated ketone. So it will occur in the presence of base. So OH, CH3, CH3. So a base which is regenerated in this reaction will abstract proton from this alpha carbon to form carbon ion. So further, this carbon ion will force the OH group to leave and it will form alpha beta unsaturated ketone. So this is the mechanism which occurs in the presence of the basic medium. So in the second thing, we can see the mechanism which occurs in the acidic medium. So for acidic medium, we can take another molecule of acetone. This acetone undergoes tautomerism to form enol, and so this acetone gets protonated by acid So again, this oxygen extracts the lone pair from the pi bond to form carbocation. So in the next step, we can write here it as enol, and here we can write it as carbocation. So this enol form acts as a nucleophile and this acts as an electrophile to give the following addition product here. So this hydrogen bond, this bond between oxygen and hydrogen gets shifted over here to form protonated product, where now this hydrogen ion loses itself to regenerate acid and to form beta-hydroxyketone. Beta-hydroxyketone. Here we can see that in both the reactions, acidic and basic medium, acid is also regenerated as well as basic is also regenerated in the entire step. So here this product can be further dehydrated to form alpha beta unsaturated ketone. Alpha beta unsaturated ketone. So let us see some examples of this reaction. In the first example, let us take acetaldehyde and let us proceed the reaction with basic medium. So what will occur in this reaction is This will be attacked by OH to abstract proton and to form carbon ion. This carbon ion will further attack on the second aldehyde mole to form another addition product, and after this we will get alpha, we will get beta hydroxyaldehyde. So this is alpha, this is beta hydroxyaldehyde. In the second reaction, let us take the example of acetophenone. So we can write the product as beta hydroxy ketone. So lastly, let us take the example of a question which was occurred in JEE Mains 2019. The question says that we have a molecule of acetophenone with acetaldehyde. So here, in the presence of dilute base, what will be the major product form in this reaction? So here we can see that in both the reactants, we have alpha hydrogens. Here we have 3 alpha hydrogen, and here we have also 3 alpha hydrogen. So, but the difference between both the reactants is the enolate ion formed by the first acetophenone will be resonance stabilized. So we can write this as enolate, which is resonance stabilized. So let us see how enolate is formed. So this enolate ion attacks on the other molecule of acetaldehyde to form addition product. So the final product of the reaction will be beta hydroxy acetone, which is our major product.